All right, man. So you have a torrent file, you open your trusty torrent downloader, you select the file, you see the file name and every other information. You click on download and you be like, wow, it's downloaded. You think you know how torrents work. Let me show you how to do it. So you see the torrent file. That torrent file got the real information, and that's the thing from where we'll get the information. Alright, man. So we got our information from the torrent file, but there's a small problem. We don't know where the damn data is. So we call tracker. That tracker is a guy, we give him our information and he gives the list of peers where we can connect and get the data. So it's a straightforward deal. To get the information out of the torrent file, we make a torrent parser, and to communicate to the trackers, we make the tracker client. But is that enough? So man, see, one conversation with tracker client isn't enough. The tracker client will get more information over the time. The peers will come, they'll change the address, they'll change the things, and people come and go, but the tracker will keep track of all of them. So we need to do multiple conversations with tracker. But the problem with tracker is that that guy actually is a very dumb guy. He gives the information of same guy again and again. So we need to do something about it. The real good thing here is deduplication. So what you have to do is you need to maintain a hash. Where will you maintain a hash? For that, we will make a peer explorer. It will be like a wrapper on top of uh, the tracker client. Or maybe you can think of it more like two guys. One guy is very much responsible for getting the peers. Another guy will be very much responsible for filtering and giving us clear. So now we got a list of peers, a really good list of peers. But is that enough? I mean, having a list of peers doesn't mean anything until unless you open a conversation and start conversation. So for that, you need a peer connection. And moreover that, you need to organize those connections. Otherwise, there are 20, 50 people yelling at you and you don't know whom to reply what and how things are being going on. So for that, you need a peer manager. Now the thing is, whatever peers we got, we will give it to peer manager. The peer manager will list whatever peers are available and spin up a peer connection, and that peer connection will contact to all those peers. And those peers will actually talk to the like these peer connections will talk to peers and get the data out of them. The data is divided into the pieces, and then those pieces are divided into the blocks. These pieces are something like a chunk, maybe 512 kb or something like that, and you can actually get the um, hash for that. You can verify those pieces. So you need to focus more on downloading the blocks, but again, you need to verify the pieces. If pieces doesn't verify, you will just reject it. Once you have the piece, think about it. Who will keep track of where the pieces are going? I mean, there are 20, 30 peer connection talking to the peers, getting the pieces, doing all their stuff they can do. The whole system is running at the beast. But who will manage the piece? For that, you need a piece manager, man. And yeah, a piece manager is another task who is talking to these peer connections. And moreover, this peer connection very much depend on these piece manager, because suppose there are three peers asking for the same piece, it's a waste of time until and unless they are all pieces downloaded and stuff. But yeah, we will think about it later. Now the piece manager actually got a very important duty to do. That's to save the pieces. It would be written to disk, so again we need some sort of disk writer, isn't it? So we have a disk writer. The peer connection actually got a very important duty to do. That is to get the pieces from the peers and to serve the pieces to the peer. And for that, we need to make the whole system asynchronous. How we will do it? The easiest way is to split the stream into two, one for reading, one for writing, and give it to two different people. That is to two different tasks. And then we don't let them talk to each other directly. We create two channels, and those channels actually talk to the third guy, which is in the middle, kind of like a middleware. And you know what? That third guy will do something called as event loop. And yeah, in Rust you have Tokyo, Tokyo have select, and that select gives you really good support for event loop. I mean, kind of like you make a event loop in your warehouse. So, yep, with the event loop, you get three cool things. One is the timeout, one is the ability to read and response, and one is the ability to tick. The tick is like a ticker, or you can think of it as a timer, which will run and check whether something is downloading or not. If something nothing is being downloaded, it will schedule something to be done. So, yep, with all that, you have the whole peer and whole seed and every. I mean, the whole torrent client is ready for you. The whole source code is available online. It's on GitHub. I will add the link somewhere in the description and you can go and open it. Surely, check it. So, now the final piece of puzzle is what I have made. So actually this is part of a series which is building torrent client from scratch, and this is the third video, and moreover that actually I have made a prototype. So this is the result of the weeks of work. Actually I should say weekends of work. You can see the pieces are downloaded, and then there is the Ubuntu ISO I have downloaded. You can actually check the hash and it does match. So we have a torrent client and it does work. Yeah, so the major thing which I did learn from this project was that how to plan and start working on a project, and yep, how to do the networking, how to manage lots of tasks in Tokyo, and yeah, the communication and how you share data between them. All right, then the coming up next would be the end game. What is end game and how it does work? So in torrent you download blocks, and those blocks are later combined and stuff, but it's all blocks, and you have a limited number of peers available. What happens is by the end of the download, the number of peers are more than number of block left, and at that time we see a situation that the blocks are not being downloaded like as good as it could, because some of the peers are slow and some of them are fast. So slow peers would actually um, hijack the whole download, and we cannot let that happen. To solve this particular situation, what we will do is we will actually change the whole strategy and ask multiple peers to give the same block, and then we will take the block from the fastest. So that's the end game, and that's the next plan. Once that's done, I will see what next to do. So with all that in your hand, now you can make your own torrent client, and now you know how to do it.